The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration podcast. Contaminants like water, acids, sludges, and varnishes may react with compressor windings, leading to compressor burnout or cause copper plating, which reduces bearing clearances, or poor valve seating, eventually causing failure. Or they can deposit in the expansion device, restricting flow or proper modulation of thermostatic expansion valves. Loss of superheat control will lead to lack of cooling if the evaporator is starved, or even worse, flooding of liquid back to the compressor, causing bearing washout and eventual compressor failure. Installing a properly sized, high-quality, time-proven Sporlan catch-all will ensure contaminants are captured before they can harm the new system components. Ask your local refrigeration wholesaler about the Sporlan catch-all filters. Parker Sporlan, leading the charge.
I'm just letting you know I'm regretting this already.
Fucking send it. Let's go.
Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're there with Brett Wetzel and Kevin Compass.
I mean, all I'm doing, I've been on this Carrier startup and it's gone not well. It's been anything less than.
You said you found something out about yourself.
What do you mean? Oh, like I'm extremely allergic to fucking PEAG oil. Like extremely allergic to it. Like my fucking hand is still all fucked up.
Really?
I got it in a cut and I could still feel my pulse through it. Like it's my finger literally swelled up the size of index finger swelled up the size of my thumb.
It's never good.
No. And then yesterday I was sick as shit trying to start up this rack by myself. So I was by myself trying to start up the CO2 rack. And the startup guy they sent out doesn't speak any English.
How's that going?
Not well. He only speaks French.
Should have got the Samsung.
I used it today. It was not the greatest.
Really?
Yeah, Prentice had one today, and it was not the greatest. So a lot of random words that weren't right. But so we've been having to use Google Translate to do everything, which is extremely difficult on a piece of equipment you've never seen before. So you're trying to ask questions and words don't line up because of the way they call things and say things. And then you're looking at a wiring diagram and everything's in French. Like all the colors are in French. So I had to go through and make a legend of what wires mean, what colors are actually what they mean in US terms.
Mm-hmm.
And then same thing with pressure settings. Everything's in bar, which whatever, that's not that big of a deal. And then all the super heats are in Kelvin.
Oh, that's standard, right?
Yeah, trying to figure all that shit out. It's this is such a nightmare trying to figure all this out. Then it's just never ending stuff. Updates they couldn't get to work. We should have started the rack 2 days ago. It was just painful.
Just the rack's not started up, huh?
It's running right now. Like the compressor is way too big to do what it's doing, and I doubt even with a full load it's even gonna load up.
Really? Is it just running off the one compressor right now?
It's running off the one compressor at 25 hertz and hasn't moved.
And that's that big ass 40 horse, right?
Yeah. I don't know. I am not impressed so far. I was disappointed by the startup out here.
You're the startup tech.
That's a problem.
No, I'm aware.
Yeah, and then they have a PLC it's a Schneider Electric PLC.
Yeah, I was trying to actually, after you and I talked, I tried to get a hold of the guy there was a guy that was posting stuff. He's over in the UK and he was posting a lot of Wago shit. And I was like, hey, do you happen to have the software for that? And he's
the Wago stuff, like they look nice.
Mm-hmm.
They're kind of hard to troubleshoot because if you don't know what you're looking at, like there's no addresses on the boards.
Yes, you have to basically know that this is input 1, this is input 2. Yeah. I get it. I get it.
The board points are marked on the board, but the actual input board 1, input board 2, input board 3, none of that is marked. If it's not clearly marked, it's not going to be easy to find.
Hmm.
I'm not a fan of the push-in connectors either.
Yeah.
They have the ones where you got to shove the screwdriver in there to get to release, like the Danfoss drives.
Yes.
And I always get stuff stuck in there.
Okay.
Yeah. Other than that, like the CC200 side was like cake. We have those down like to a science now. It's so much easier with those case controllers. And they're doing them over IP this time, so it's 10 times faster.
Really?
Oh yeah, dude, it's like cake setting them up now.
That's kind of
And
amazing.
then being able to ping them from a computer to make sure the comms are all good, and it's I don't know, the CC200 side's like cake. We had everything. Our side was like perfect and ready to go, and then it was just hurry up and wait for the rack manufacturer. Yeah, it's 7 o'clock, dude. Like we got to get this done. Like I go, I need you to be here at 7 a.m. He's like, oh, like you could just tell it was.
Besides that, how's your team?
I mean, besides being like half dead yesterday, not as bad today. I finally got help.
You sound like you were dying yesterday.
Oh, I was
Like a
I
lot.
think 102 fever.
Oh, really?
Yeah, I literally went home, drank like a quarter bottle of NyQuil, and I slept for 11 hours.
Beautiful. At least you got some sleep.
I hate you.
I know. It's mutual sometimes. So, I don't know. We didn't even talk about what we're going to talk about. What we're going to talk about.
I don't know. What are we talking about?
I don't know. I have no idea. No idea. We usually argue over it for about a good 10, 15 minutes. By the way, thanks for putting your name in there this time after I didn't realize for about 2 weeks. So,
Oh my God, it's so funny.
thanks for that. Probably going to get calls over that.
No, just think he really got to me, and I'm really taking his advice.
Well, maybe you should be better and you wouldn't be so angry. And
I'm not angry. I just
I'm going to agree to disagree. When you get calls that say, Mr. Kevin, you can be a dick, then
that was James, also not me.
Wow.
He was also angry.
Oh boy. I have no idea. All I've been doing is I've been on meetings nonstop this week. That's it. Trying to get my butt in different areas, going out to Connecticut next week. Yeah.
That's where you're from.
It's not where I'm from. It's where
Yes, it is.
It's where I lived.
It's
Big
the same
difference.
thing.
No, it's not.
You didn't get some of that shitty ass pizza they have there?
Actually, I'm thinking about after I get off Bradley, I'm getting there at 5 o'clock, I think, on Monday night. So I'm gonna get some good pizza.
Fucking trash pizza.
No, it's not. You live in Indiana,
Yeah, but we have Chicago pizza.
which is a coronary attack and way too thick of a crust. I don't dig it at all.
It's better than no crust. But all right, let's talk about something here. Not Brett and his shitty pizza. So we could either talk about how this carrier rack works.
I hate you so much right now.
That's fine. You chose this, not me.
I didn't choose anything. You were the one who just happened to do this today.
You chose this life. It's okay.
Fine. Everything's fine. Nothing's on
Jesus
fire. All right. I guess then I'll bring up some information on the carrier rack then, since they don't want to come on yet and probably now never will.
It's okay.
Anyway. I hate you so much. I guess that's not going to happen anymore. Thank you. Thank you for that. I'm looking for the PNID that I made. So I'm going to bring up the one that is comparable to the one that you are currently working on so we can discuss that one. And then we can discuss the other one, which is more along the lines, whatchamacnuts it. Stop it.
You're gonna have to edit this whole part out anyway.
You're absolutely fucking right. I am. I hate you again. Is probably sitting in his house vacuuming, and he's going to hear this, and he's going to keep laughing because he knows what it means. All right. Anyway,
it doesn't matter because at the end of the day, they don't buy Copeland compressors. So
This is very true. What do they have on there? They have the green ones, yeah?
yeah,
I hate you once again. All right, so I'm going to share the P&ID, and then we can discuss the flow of the refrigerant and then discuss how this thing is supposed to work, Kevin.
sure. Let's go, Brett.
All right, so anyway, so here's the P&ID for this particular piece of equipment. And not every single rack has, does yours have the heat reclaim?
No.
It does not. So coming out of the discharge of the compressors, going out, going through, if it did have any heat reclaim, whatever heat exchanger it might have. Does yours have the gas cooler bypass, or is it just straight up?
Just straight up.
Okay, so Kevin's does not have the three-way valve. I'm going to zoom in a little bit so we can look a little bit easier. Flow goes out from the gas cooler, goes down. Instead of going right to the HPV as we're all accustomed to, it takes the discharge gas, runs it through, oh, I'm sorry, it would actually just be the desuperheated gas at that point if it's running transcritical, runs through this little heat exchanger right here, and we'll get to that in a minute. Because one of the things that you probably did notice while we're rolling through there is no oil separator. This particular piece of equipment has no oil separator whatsoever, and it has to do with the type of oil, but we will talk about that in a minute. The line coming out of the gas cooler, it's desuperheated, rolls through this little heat exchanger. It's like a tube and tube, correct?
Yes, it's like one of the case ones you would see.
Okay. Gotcha. And then once it goes through there, it goes through another heat exchanger. And if you actually look, that actually goes to the suction. So once again, once it goes out through there, goes back up through, damn it, I lost it. Okay. Out this second heat exchanger, which is actually for the suction, and then goes back up and into these little valves right here. They look like they're actually ejectors. They're stepper ejectors. But when you're utilizing them without the line, because usually on the injector, you have the discharge gas going in, and then you have basically the liquid being created on the HPV here. And then you're usually sucking out this side port here, usually stealing some of the capacity from the medium temp cases to basically reduce the load on the compressors. That's why ejectors are really efficient at really high pressures, because it's basically stealing some of the capacity from the cases so the compressors don't have to deal with them. And coming out should be your liquid, filling up your flash tank. You still have a BGV over here. And then there's your medium temp consumables. That's what they're calling it, medium temp consumers. There's your suction gas coming back from there. And then off the bottom here, this is where your liquid is. Now, you'll notice that it does not have an oil separator. And the reason for that is it uses PAG oil, which Kevin found out he's extremely allergic. So make sure you're wearing gloves. But anyway, so what it's doing is it's actually just putting the oil all the way through the system and going up and actually getting dropped into the flash tank. And the reason why this is okay is because PAG operates opposite of regular POE oil, where it'll actually sit on the bottom of the liquid. PAG oil is used in ammonia. They do basically the same thing. They have oil pots at the bottom that actually catch that oil, and they usually just get rid of it. But in this case, we're reutilizing it. So the oil will sit on the bottom, ends up going into this little standpipe. There's a diverter piece to help prevent the oil from actually going out there. That's also why the liquid feed off of the right-hand side here is raised up a little bit, so that oil cannot just directly go down and out and through the liquid line out to the cases. And so the oil will sit in the bottom of the standpipe, go through here, and then get redistributed to the compressors. The problem is, what flash tank pressure you're running? What's saturated?
515.
Okay, I was confused. So what, 36 degrees, something like that? Yeah.
Yeah, something like that. It's really close to that.
All right, so we're running around 36 degrees saturated, so that means that oil is going to be super, super cold. And as we all know, CO2 is extremely miscible with the oil. So what they're doing is the oil is going to sit down in the bottom of this flash tank, get redistributed over here. But before, that's why we actually take this discharge line and run it through this heat exchanger to warm up the actual oil. You'll notice that there's, if we zoom in a little bit, there's 3 temperature sensors right over yonder. There's no sight glass on there, correct?
Correct.
Okay, so the only way, basically, these temperature sensors, you can tell where the oil is because theoretically you should be, if it doesn't have any oil in it, the temperature is going to be exactly what the saturated temperature is of the flash tank. But because you have the oil at a certain range, let's just say the sensor would be at 36 degrees because it has no oil going up to it. And then these would be significantly warmer. I think they said about 2 or 3 degrees warmer than what the actual flash tank saturated was. And so that's what they're doing. They're warming up that 36-degree oil by basically taking the drop leg temperature and running it directly through this heat exchanger to warm it up. And that's what this one's for. That's to mitigate any low superheat that you might get from your BGV or your basically your medium temp cases.
Yeah, except for when you have no load, it doesn't work.
Oh, the heat exchanger?
Yeah.
That's no good. Yours has the sight glasses on there. It's using the what are those? Those are Emerson something 3s or something like that. I forget what they're called.
Yes. Now, the only thing I found with those is I've had it with Carnot. I've had it where they've not put them together correctly, and the little float ball in there that falls off. We didn't have any in this. Yeah, it happens quite a bit.
That sounds fun.
No, so that's been a thing. Other than that, it hasn't been too bad with the way it was designed. It could have always been worse, but I'm skeptical of what's going to happen when it's in a low temp, low load situation, because if you don't have anything to heat the oil, how are you going to get all the refrigerant out of it? You can't tell me there's not going to be any refrigerant liquid in there at all. If you lose oil, say if this thing starts pumping oil, and if you lose oil, you could pump some refrigerant through those crankcases pretty quick. If you get washed out because you had a washout situation or something happens and you lose oil, that's going to be a problem.
I see. I don't know. I'm at a disagreement with you because even if you have a washout where it's going right through the discharge, it's going to be going directly up into the gas cooler and then coming back down and then getting pumped back into the flash tank anyway.
Maybe. Allegedly.
You say it a lot. Plus, here's the thing: you don't like anything that's new, though.
That's not true. This isn't new.
It's new for you. So on yours, do they also have the accumulators on the section for the low temp as well?
No,
they do not.
Only medium temp.
What? Really?
Yeah.
Oh, the medium temp doesn't have shit on this one.
Exactly. Mine's just the medium temp.
Oh, okay. Understood. Okay, understood. So the only other thing is too, which is different with this, which you will see if you do have the dual temp one. So typically we're all used to the discharge going into the ass end of the suction of the medium temp. On this particular dual temp type of rack, it goes directly into the flash tank, which is okay because if the oil is separating within the flash tank, then it's fine.
Yeah. I don't like it when they put the low temp into the flash tank because it makes it more volatile and it buys you less time if something does happen because you're warming up that flash tank pretty quick.
I get it. But there should be enough volumetric space in there that accommodates to that.
I would hope so.
Yeah. As you would say, allegedly. The other thing about these racks, from what I was informed, is that these valves right here basically work in unison. So this one opens up first, and then this one opens up, and this one opens up, and this one opens up, this one opens up. So it basically shoots back and forth. It doesn't utilize one and then utilize another. It baby steps these back and forth.
Correct. Yeah, it's doing them in parallel. It starts loading up one and then the other. I think it would be a lot cooler if they use the ejector, and it would handle the superheat a lot better with the way they're doing it with the ejector, because their whole thing is with the ejector that it's going to handle the superheat.
Oh, because it's basically almost being like a liquid injector at that point.
No, because it's not. I don't want to say this. It's not doing. It's taking most of the suction gas on the medium temp.
Yeah, I don't know what the percentage is of that. I don't know how that works. I'm actually have a meeting tomorrow. So that pack software that we were playing around with the one day, where I said we need a real engineer. So one of the guys from Future Green, like, he uses that software a lot. So he's walking through the software with me tomorrow, so I could understand that. And I'm going to ask basically how much percentage, and I guess it would have to deal with how high the head pressure is. Probably the higher the head pressure, the more it's going to actually consume of that medium temp suction gas coming from the cases.
The higher the head pressure, the more work it's going to do.
Yeah, the more it's going to suck out of that side port there. This is what the ejector kind of looks up like close up. But on that particular rack that I was just showing you, apparently they have 3 different versions of this. So you have the one that we were just discussing, which is, oh, I just lost it. Nope, that's not it either. Oh, damn it. Which is this one where you actually see that there's a ball valve, and then they have it X'd out where it's basically just capped off. And then they have the other version, which is actually utilizing the actual medium temp suction, like all of it.
Really?
Yeah, look.
Yeah, it's that version would be a lot better, to be honest to you.
Yeah, so look there, and actually I think, if I'm not mistaken, there's something special about this, and I forget. We walked through this whole damn thing. There's a ball valve right there, goes down there. It's a suction. Oh, so yeah, so it basically acts almost like so check this out. So it pulls, because it's using that all through the ejector. It's pulling the suction gas off the top directly off of here, and then going through here over to the suction, and then basically using that pressure to help push the liquid back out to the cases.
Yeah, it's just dump it. At that point, your only load on the rack or the compressors is your actual flash tank pressure. That's it.
Yeah, and your low temp blowing into them too, right?
The low temp's going into the flash tank.
Yeah, but it's still got to take the vapor off of that, whatever it's going to vaporize.
Like, the only load is the flash tank at that point.
Oh, okay, I see what you're saying.
Yeah, so like you're only pulling off the top of the flash tank, which you're less likely to flood out with the load off the top of the flash tank.
Today's episode is sponsored by the RefriShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
So I will say this, the other thing we had problems with is the HB liquid sensor, which I'm pretty sure it's bad. Yeah, that thing, you're pretty much SOL with those things unless you have the computer program and the special adapter to plug into it.
Wait, you said
HB. So the HB liquid sensor at the bottom.
Where is that?
It's at the bottom of that tank, right where the outlet of the tank is. Right. So to the right. So scroll in the tank. Right there. See where that probe goes up?
Right here?
Yes.
Oh, L7, L something 70, LT70 or something like that.
L something 70.
Shut up. Is that what? That's a liquid probe that's actually made. Is that upside down?
Yes.
What?
Yes. Don't
Why
get me
would you do
started.
that?
The numbers are upside down on the gauge. It's extremely irritating.
All right. That's once again. Let's have that discussion again, where we should have that external sight glass type thing. Off
Yes.
To the side.
No. So here's the thing. So that's toast at my site, and they can't get it to the zero out. Okay. So whatever. So they can't get that to work. Now we have the problem of we don't know how much liquid's in here.
How much did you put in?
500 pounds.
And what does it say it's supposed to be?
Those are never right.
I'm asking.
It says 200 pounds. So to all the stores. that I've done. So like it's like 200 or 300 pounds. But nobody knows how much you can get right now. So I went till the cases stopped running warm.
Mm-hmm.
So yeah.
Do you have everything? Do you have all the load on that rack currently? Or no?
Fuck no.
Okay.
We have one shopping box.
All
So
right.
now you're playing Russian roulette. Is this enough? Maybe, because if they would have put a sight glass on there, it'd have been fine.
You could. Oh wait, that's all insulated, right?
Yeah, like
I was gonna say at least you could put a temperature sensor right there on the side of the flash tank. You know what I mean? And see exactly where it's saturated and then where it starts superheating to get where your level's at, right?
yeah,
But then you'd have to cut into your beautiful.
it's pretty well insulated.
Is it really? That's what I was saying. You wouldn't want to do that, right? I am looking.
What?
I'm looking for your. I know. I'm just. I don't want to try it now. I don't want to stop selling me stuff. No, I'm looking for your schematic because, like, we talked about this, and apparently, I just now can't find it because I have the whole file here. But like, how much shit did I send over to you? Oh, there we go. Electrical schematic. I know I did. I know. So anyway, I get what you're with the schematics. I get what you're saying. But anyway, so let me open this up some and I'll share this because then we can go through this. If you do have a digital copy, at least you understand. Oh my God, shut off your phone.
Keep talking.
Present, share screen. Anyway, through the schematic that they have here, one of the nice things is that you should be able to click on each one of these devices and it actually brings it up to where you have to actually go in the schematic. So when you click on this, it highlights in red and actually takes you right where the Wago block is. And so this is what Kevin was talking about. So like this is marked AI5, this is marked AI6, this one's marked AI7. So in order to figure out where we were before, we'd have to go to the other Wago. That's not what I wanted to do. Nope, that's not it. So you can click on one of these things and it actually takes you to where that device actually is. So if we click on, let's see, let's go to this one, 7, which takes you over AI 9 through 7. So that's how you have to figure it out. So each one of these boards is a different thing. I actually had to look up every single one of these part numbers because it wasn't in the guide. It unfortunately in the book and whatever they send you in the schematic, it basically just gives you like the board numbers. So without really going in and tying in and try to figure out what each one of these things is, you got to do some research. But what you can do is I have a whole bunch of documents. Where are we at? Wago. So Wago has everything on their website. If we open up this one, so this one's the analog input module. So you can see right here the 13 and 14. So like right here, 13 and 14 right here. So the 451, the 75451. So then if we go back here, 750, 451. So we know we have, this is an analog input, this is an analog input, this is an analog input. Then we open up the next one, which is a, let's see, 557. So the 557 is a analog output. Unfortunately, though, you can't really, from my understanding, you can't change anything within the program of how it sends the analog output out unless Kevin's found something out that I just didn't know yet. But there's a software that you should be able to get, but it's from Germany. And you can actually, I think you can go Ethernet connector onto the actual Wago board here. And if you do so, you should be able to probably communicate to all of these and then potentially change the program to this. Kev, you have one Ethernet currently going from here over to the main PLC, correct? On the front?
Yes, there's one Ethernet that goes to a switch,
Mm-hmm.
and then it goes to the PLC.
I haven't done it yet. Like I said, I haven't been able to get a hold of the software because everyone wanted you to register for it. But what I'm assuming, and we all know what happens when you assume, but you should be able to probably connect to probably the X2 and then get in and actually change a lot of these parameters within these Wago connectors. So Kev, you were having a problem where they, in the spec, they wanted 10 to 0 for the gas cooler, correct?
Correct.
Yeah. So they couldn't do that. And so I did, after you told me that, I started looking, because I don't know, I'm a pain in the ass, but it didn't look like the options for that were able to do that. Unless you found out something different.
As far as I know, no.
So the fans are still running full tilt?
They are running 0 to 10. So
Okay.
if you lose your fan, then you're pretty much SOL.
You can override the controller at least.
Yeah, I guess it's not ideal, put it that way.
No, I get it. But yeah, so that's what I think what Carrier should do, is probably start putting a lot of this information within their actual books, like within the information. Because the only reason why I have this is because I literally tore apart like all the information that I got, and then just started going into this deep dive hole and like trying to figure out what this thing was, because it really doesn't tell you. It shows you where it's connected to, if it's connected to a pressure transducer or whatever, but it doesn't specifically tell you like what this M is, which one the positive and which one the negative is and shit for this. So going back to the schematic, so then we have these other boards, these 468s. So the 468s are I think they're just regular analog input. Yeah, so these are the analog input, 4-channel. And because all those temperature sensors on all those are, you said those are PT1000s, correct?
Yes.
Okay. At one point, so that's why that you have that one pressure transducer document, because they said that the one that I was dealing with was 0 to 10 pressure transducer, but you said yours was the milliamp one, right?
Some of them were milliamps, some of them were 0 to 10.
Oh, interesting. So on here, so you have 4 potential signals. So you have ground, common ground, shield, and then there's all your AIs. So AI1, AI2, AI3, AI4. I'm trying to see where it says what components you can tie in, because everything's going to be, probably won't share it here. There's probably another programming guide that I don't have. And a lot of the stuff is in German. I got some really good pictures, but then I had to basically use AI to translate what it actually was saying. And then you have the 602 board. One of those is a power supply. I think the N one is a power supply, if I'm not mistaken. Oh, never mind. The 753 is the power supply. So that's probably the one that's actually powering up your 4 to 20 milliamp transducers, yeah?
Correct. And then there's another one that's powering up like your transducer for that liquid level gauge, because it's 4 to 20 milliamps also.
Mm-hmm.
So that one we had, that was wired wrong on the drawing. It had a black and white wired wrong, so it's probably what toasted the sensor.
Did it toast the sensor, or did it toast the input?
We're pretty sure it's a sensor because it's not getting anything out of it anymore.
Gotcha. All right, and then what's the other one we didn't go through? So the 455, did we open that one? No, it looks like we didn't. So the 455. There's your 4 to 20 actual inputs. One of those the card that we just looked at, that's going to be the one that's actually powering up the power for the 4 to 20 milliamp, and then you have this one, which is receiving the basically the signal back for that.
Correct.
Okay.
So I will say this, okay? When you're going through these, the wiring diagram on paper sucks ass. Doing it on a computer or an iPad is 1,000 times better, because, okay, as you're moving around to stuff, there may be stuff. It's a lot like a Carnot wiring diagram. So there's stuff on multiple pages.
Yeah. So this right here. So it says 38.5A. And then, yeah. So look, so this is actually how to read this. Let me see if I can move this piece of
Yeah,
shit
let's
out.
go over this because this is very important. Because if you guys don't know how to do this, you are going to be lost.
Yeah, because I was looking at those numbers the one day and I couldn't figure out. Why can't I move you? Move out of your fucking piece of shit. Anyway, so you can see right here, it has down here on there. It goes away. So this is page 38. Okay, and then it said A. What the fuck did it say? A. It was A5, right? No.
Correct.
Yeah. So A and then 5. So it's basically showing you there's your number right there. So then it goes back to there. So you have to know how to utilize this. So like then that other one should have been something 30, right? So it's probably, I don't know, H7, or it would be 30H7 or something like that, because it's page number first and then your vertical line and then your horizontal line to actually find where it is actually on the page. So it's really handy, like as Kevin said, to know how to actually utilize that. If you don't know, if you're trying to fumble it through it with the paper, it's confusing. It's a lot easier just using the computer, because look, I can click on this. All right, let's just say I don't know what the 600 card is. All right, the 600 card went over here, went to page 39F. So I go over here. Why didn't I go to that? So then it's showing you on here. And so if I roll down to page 30, right there, 9, and then F, and giving you this right here. And what's this? A9, and that's the A9, A11, what's on there. And then also the same thing with this, because you have other pages here that goes to other stuff, like right here, where this is where it's showing you where everything's connected to the temperature sensors. What is temp hula? Is that the French you were talking about?
Yeah, there's multiple things in French that are very confusing.
Temp sortie CO2. What's temp sortie CO2?
Hey, it's temp sortie CO2. You don't know about temp sortie CO2?
I do not know about the temp sortie CO2. What
The
is
temp sortie CO2?
Do you not know what that is?
No, I have no idea. Hold on, bringing it back up.
You actually made a translator?
Like I literally started making words, just taking it on ChatGPT and just crossing them over. Like
temp sortie CO2.
Then the apprentice was messing with his phone and putting it in there.
Yeah, no, I was trying to say it, but I'm pronouncing it way fucking wrong.
Yeah, I don't like that they don't have terminal blocks here and they don't really designate field wiring, which I went over these guys with. I'm like, it doesn't really designate what is field wiring and what is not field wiring. Trying to figure out what the electricians had to pull this rack, nobody had any idea.
Well, what would they have to pull the rack though?
Your outdoor air temp sensor, your gas cooler supply signal, you got your gas cooler fault, you got your you have your drop leg temp sensor. That all has to get pulled, but none of that's on a print. This is driving you crazy, isn't it? That is not what that is.
Definitely not.
Close.
I'm just gonna let this bother me.
Yeah.
Oh my god! There we go.
CO2
temp outlet temp. All right.
Yeah.
You didn't know that?
But yeah, that was another one that took a while to figure out. And then outdoor air temp was called something weird too.
Temp Huli? Look, CO2 temp CO2 outlet.
I was just shoving sensors in this thing because I couldn't figure out what it was. Between that and the outdoor air temp, I was shoving the sensor in there and seeing which one read in the HMI screen. This is ridiculous.
Oh, hull temp. Oh, that must be because there's 3 of them. Oh, look, because there's 3 of them. Those are probably the ones that are on the.
Those are the oil.
Yes.
Tree.
See, it's not that difficult. I don't understand why you're having such a difficult time with this. This was fairly easy to figure out.
Yeah, with ChatGPT and you're sitting in an office, it's a lot easier.
I'm breaking your balls. Relax.
Than being on a roof and your phone dying constantly. I will say this though, they put some nice lights in this thing. They're on a cord and you can move it around.
I hate you.
I asked the guy that. He just started laughing. He had no idea what I said.
He's just yeah.
He's shaking his head. I'm like, this is great.
Oh.
Other than that, when we finally got it started and we bypassed the MOPs on on all the CC200s for 10 minutes, we finally got this thing rolling after it stopped fighting the suction on the rack. It was somewhat okay.
Gotcha.
The CC200 integration was a pain to get going too, or not the E3 integration, just for the fact that it was like trying to get them to tell us what they did, like what their baud rate was, and like the way they say things was extremely difficult.
Gotcha.
A lot of language barrier here and time barrier. So that was the other thing.
Oh, because they're like 11 hours difference, aren't they?
Yeah. 10 o'clock at night when he's talking to these guys.
Yeah.
So like his support was like shitty. So I feel bad for the guy, but because it's an 11-hour time difference.
Yeah. Other interesting thing is with the PAG oil, if no one knew, I didn't know that if you put POE oil in there, it turns into shaving cream within the compressor.
It also eats your fingers.
I think that's just yours. I think I think this is it might be the first rack that's actually fighting you back and like really doesn't like you. So it's trying to kill you.
Maybe.
It's just a thought.
Was going to say. Other than that, it's not too much different than a normal rack besides the oil system. And I really dislike the fact that there's no level indicator on the receiver, no balls or anything. I really don't want to cut this thing open tomorrow. I know I'm going to have to.
Yeah. Maybe one day we'll get Michael on here. The guy that basically invented green and cool.
Oh.
And get him to talk about this.
Maybe they can get you to reduce some of their screens.
Yeah. I didn't get to see it yet. I told him I was like, we were talking about how they had a trainer or whatever, and I was like, if you want, I could have one to play with and see what it does. Aren't you regretting now not keeping the stuff in that other rack?
No, God, no. Threw it
Why?
out in the garbage and it was the happiest day ever.
Yeah, I hate you. Was everything it was? Did it was able to go in? Oh yeah, so it looks like it does. Was everything bar or PSI?
Yeah, it will, but unfortunately, it leaves the superheats all in Kelvin, which is it was a fucking pain in the ass. So I had to download a converter on my phone.
Isn't that just Celsius? Someone told me that it's basically Celsius, unless that's wrong. Because every time I try to figure it out, it like ends up being like negative 468 degrees or some shit. And that's not it, because it's degree indifference is what it is.
Yeah, I don't know. I just downloaded a Kelvin to Fahrenheit calculator.
Gotcha.
So that's goofy. Good.
No, so did you finally get a copy of the prints for that particular one that you're working on?
God,
I find it weird that they like changed it. Like that, I went through this and it wasn't even 3 months ago, and they're like, this is how you either have this version or this version. And then maybe it's because it's the medium temp and you don't have the discharge gas blowing. I don't know. I just, when you said no, that's the actual discharge line going in there, I was like, no shit.
As far as I could see, it's the discharge line. Okay. Like I'll trace it back out again tomorrow, but it's like right in line with the discharge line.
No, but you saw it. It should be the line coming off of the gas cooler, basically the drop leg.
Yeah, like this one, I'm pretty sure the drop leg comes in and hits one in the back and hits the suction.
It's going to bother me now.
Because the suction, I have 10 zeros on racks that are supposed to be the exact same. They're all different.
Fair enough.
They change little things, but I will say the other thing is pretty friggin' annoying is the locks and the doors.
What do you mean?
They're all like the cabinet locks.
The one that has the circle with the two little ears on there. That's what a lot of industrial equipment uses. They like Kaiser or not Kaiser. I say
Carnot does some stuff like that. The Gutner gas coolers are like that. The only thing that sucks is you lose the freaking key, and then you got to like kind of half-ass mangle it.
No, Ingersoll Rand uses that. I can't remember. I haven't. It was like a bunch of the air compressor manufacturers just use that same freaking key. But even on the control cabinets that's a standard. It's better than something that's gonna break off.
A door handle's not gonna break off.
Says you. Whatever. All right. I guess that's it. I don't know. What are we gonna do next week?
We could talk about Copeland stuff, either CC200 stuff, since I have a bunch more experience on these now, or we could talk about some Dixel stuff.
Yeah, you said this one you did just straight up.
Ethernet, so much easier.
Really?
Yeah, it's fucking cake. I understand it after I had Chris Denny send me that list of how the octaves work. It's so easy.
Oh, cool.
The only thing that sucks is you got to change the Ethernet 1 in the E3 from its normal address to a different address, which sucks if you have a mini router already set up like I do.
Mm-hmm.
It won't work for it.
Actually, one of the things I was doing today, I have that 880 that I was trying to get a talking, and I got it working to the point where, because the problem I was having, I couldn't get the pack controller to graph, and what I found out is that you actually have to go into the pack controller first, and then set up the logging, and then it'll pull back to this. So you have to enable the logging on the pack controller. That's something I would really like to talk about one day. Yelling at me.
Oh, the pack controller.
Yeah, we'll talk about that another day. But all right, man.
All right, guys. Thanks for listening.
See you guys next time.